I'll give you a brief introduction of who Tecplot is for those of you who may not know, and then we're going to go into a discussion of how buying a full version of Tecplot 360 and taking advantage of batch mode can really help save you time and get your work done faster. So Tecplot, who is Tecplot? Well, we're a bunch of geeks who love visualization and love data processing. You know, visualizing your data is, like Sam just pointed out, it's getting the data off disk, which is a really big bottleneck in that whole thing, and we love optimizing our code, love helping you get the most out of your data. So sometimes we call Tecplot 360, we call it about being, it's all about knowledge extraction. How can you extract the most from the data that you produce? So our history, we were founded in 1981 by a couple of engineers at Boeing who were actually writing CFD codes themselves, and eventually they said, well, how do we visualize all of the numbers that are coming out of here? So they hired a developer at Tecplot. He's still there today, employee number one, and built Tecplot, the product. We've really grown into being what we think is the largest independent CFD post-processor in the world with about 47,000 users, CPFD helping us get there as well. And really a flexible product with integrated XY, 2D, 3D, and even polar plots. And we're really focused on helping the emerging needs of the CFD community. So data gets larger, you need faster processing, we're working on that. So we're really celebrating 3 years of Tecplot for Barracuda, and actually it's been a couple more years in the making. I was just looking back at my history of talking with Jim about exporting Tecplot 360 data, and that was back in 2017. So we've been at this a long time, we've been partners for a long time. It's really exciting to see where things have come in the last 3 years, and most of that during this weird COVID time where we haven't been able to see each other in person. So CPFD has been really generous in giving you guys access to Tecplot 360 through Tecplot for Barracuda. And so what do you get from that? You get use of Tecplot 360, but it's limited to Barracuda data only. You get use of PyTecplot, but it's limited to only being run from the user interface. And we don't throttle any performance. A lot of times in these partner contracts where people distribute somebody else's technology, it's throttled a bit. We don't do any throttling, so you are getting access to all of the CPU count, so you're getting all the performance out of Tecplot 360. And of course, distributed by CPFD and their Tier 1 tech support, but we're Tier 2, so we are here as a resource for you. So if you ever have a question about how to use the product to get the most out of your data, please contact our support group. So what do you get with a full license of Tecplot 360 if you actually paid for it out of your own pocket? Well, you get more presentation options with multiple pages, multiple frames. I've seen a lot of multi-frame images today, which look great. What is multi-page? Multi-page, think of it as like a sheet in Excel or another page in a PowerPoint. So you can really organize more data in a single Tecplot 360 layout. You have the ability to load data from other sources and other solvers. So I've seen a lot of presentations where you're comparing experimental data alongside your simulated data. So you can bring that experimental data in from Excel spreadsheets, unformatted text files, etc., or other solvers, which I've seen here today as well. So if you're looking at comparing one solver with another, you can load that data into Tecplot 360 with the fully licensed version. Faster automation with batch mode, and that's really what the focus of this talk is going to be today. We're going to focus on a couple of use cases that came through CPFD support. So what does batch mode get you? You can run completely headless on an HPC, you can run distributed, you can also run on a local workstation using multiple processes simultaneously. And Tecplot Chorus is a product that comes along with Tecplot 360 for really helping organize optimizations and design of experiments type work. So for those of you who haven't used PyTecplot, what is it? It's the API to Tecplot 360. You can record PyTecplot scripts directly from the Tecplot 360 user interface to really help you give you a head start in scripting. So you don't have to sit there and sift through the documentation to figure out how to use it. You can just record a script, and that'll give you a great head start. We support 64-bit Python, Python 3.8 and newer. We try to stay up to date with the newer versions of Python. And we really designed this API to run in such a way that you're in control of the flow of the script. Tecplot macros can be difficult to debug sometimes because Tecplot 360 is executing it, and you don't have a time to hit breakpoints and really debug things. You can do that with Python. The really powerful thing is it gives you access to the direct data. So you can jump into the data, you can pull arrays of data out for doing data analysis, and we're going to show that today. Truly headless, and you can even use, say, Python toolkits like PyQt to create custom GUIs. So here's a really simple script. This is not going to be a tutorial on how to write Python, but just a couple of import commands. So import Tecplot as TP. We like using this little alias for it. Connecting to the user interface. So if you want to run it in what we call connected mode, which is how you have to do it with Tecplot for Barracuda, you're connecting to the GUI. Here we're just specifying what files we want to load them, apply a style sheet, and then we'll just loop over all the time steps and export an image. So the API is pretty simple, it's pretty expressive, and there you go. And by using some of the Tecplot file formats like the style sheets, you don't have to write reams and reams of code to get the plot style that you want. So that's the great thing. You can set up the plot style using the GUI, save that off. Your script is a lot smaller, a lot faster to write, and easier to read. Okay, so let's talk about a couple of analysis tasks that came. These came through, both of these I think came through Sam and Rosemary, and they've been a joy to work with. And the thing I love about working with the CPFD staff is we grew up doing aerospace CFD, right? So this is some of this is a bit new to us, and the fun thing is trying to solve these new problems that we haven't seen before. So Sam and I actually did a webinar on this case, and maybe one of you in this room said, can I quantify the bubble characteristics in a fluidized bed simulation? And we scratched our head a little bit. Sam said, well, we want to compute the size of the bubbles, we want to compute the rise velocity of the bubbles, and so we spent a little time tooling on this and realized that Tecplot has the building blocks to do this. I like to think of Tecplot 360 as a box of Legos, right? Sometimes you have that nice kit, you can put it together really easily, but sometimes you have to spend some time thinking about how do I use this, what piece do I use to do the analysis that I want. So the answer was, yes, we can do this, but it's going to take a little bit of work, and we had to create that new Lego piece. So we came up with a set of steps, and we actually, like I said, Sam and I did a webinar on this. We have the Python script available on the Tecplot website for how to do this whole thing, but we used a capability in Tecplot 360 called value blanking to define or isolate the regions of bubbles. And then we actually created a new capability called extract connected regions. So once we used value blanking to identify each one of these bubbles, we were able to extract each one to a separate zone. A zone is kind of Tecplot's unit of data. And it's the currency that we deal with. And from each one of these bubbles, we were then able to use a capability in Tecplot to integrate the volume of those and then compute the average z velocity or the rise velocity of each one of those. And this was all done in Python, and then we took those scalar values that we computed and we put it back on the data set, so you're able to see the coloring of each one of those bubbles. Now you can see this is a pretty coarse data set, but we were able to get it done pretty easily. So if we look at the Python script that we had to do, it was only 60 lines of code. So pretty short script, pretty expressive API as well. We wrote this in such a way that we could do this repeatedly with other data sets, and it executes really fast in batch mode. Connected mode, it took 23 minutes to do this analysis, and in batch mode, 37 seconds. But then if we used a Python module, and this is one of the great things about having a Python API, is you can connect with other Python modules out there. So we used a Python module called multiprocessing. So We took this script and it would effectively load each one of your time steps in a separate process and do the computation. So you're effectively getting more parallelism, and we got it down to 7.3 seconds. Now, you guys are used to, I mean, we heard Jim say, many days, 16 hours. So, 23 minutes, that might be fine for you, but that sounds like a long time for me because post-processing usually goes a bit faster. So we were happy about getting that down to about 7 seconds. So, okay, connected mode took a long time. Let's talk about why. Why is connected mode slower? It's not because we are slowing it down on purpose. It's because the way that we set up this API is connected mode communicates to Tecplot 360 via sockets. And that's just inherently slower than working direct memory. So PyTecplot in connected mode drives the Tecplot 360 GUI, so you have the user interface up. So it's a great way to do, say, a partial workflow and then continue your work in the GUI. Again, it's done through socket connections. It's really great for developing and debugging PyTecplot scripts. I find myself using this connected mode quite frequently when I'm developing a script and trying to understand how to do the process, make sure that I'm getting the right answer, and I usually do that with 1 time step or 2 time steps and use it for development. But it's not really great for data analysis because we have to pass these large data arrays across the sockets, which is definitely slow. Batch mode, again, truly headless, uses the Tecplot 360 engine. So Tecplot 360 is built on top of a set of C libraries, so it runs very, very fast. It's really good for data analysis because we're actually passing those arrays just as pointers, so it's very quick. And then you can run embarrassingly parallel to get your work done faster. Again, the way that Barracuda writes out your data, each time step is a separate file, so you can really easily distribute that across multiple nodes of a cluster. Okay, so now that we've got the slowness of connected mode and the fast of batch out of the way, let's move on to the next case study. So we had another person say, can I identify the region of minimum pressure with respect to height? So again, well, there's no magic button in Tecplot 360 to do that. So we, again, spent a little time noodling on that. What are the steps that we need to take? Where are those Legos in the box to build that analysis? And we said, yeah, we can do that as well. So the steps to do that is we used slices at regular Z intervals, and we extract those, again, to Tecplot zones. Again, that's the currency, the data that we need to evaluate to find those regions. So we extracted slices at regular Z intervals. We used PyTecplot to locate the cell in each one of those slices where the minimum pressure existed, and then we could determine the XYZ location for that cell number, and then we take all of that data that we extracted, create a new zone which contain the results, and that's what you're seeing here, this red line. So that's the location of minimum pressure at each Z location for this. Okay, so said, well, for this presentation, I said, why not look at max as well, because it makes a better looking line plot. Again, magically, it took 60 lines of code. Again, I'm not making that up. I mean, both of these scripts took 60 lines of code. Now, this data set was 361 time steps. It was only 7 gigs of data, so not that large in the scheme of things as far as data sets that I've seen come from SAM. Connected mode, it took a long time. And in fact, I only ran about 20 time steps, and I just did the math to figure out how long it was going to take, because at 510 minutes, that's too long for me to wait. But then doing it in batch mode got it down to about 776, so it's about 12 minutes, and then running 32 cores, 37 seconds. So, and just a note, all of these tests were done on a Windows workstation, running Windows 10, 40 cores, 128 gigs of RAM, but we didn't get anywhere close to that amount of RAM being required. So really what I want you to take away from this is Python is a great way to do advanced analysis in Tecplot 360, or with the tools that we provide. Not everything is built into the GUI, but I will also encourage you to, if you have a specific analysis that you want, let us know, and we can either work up a solution for you, or eventually some of this may get wrapped into the user interface to make life easier. So in summary, Tecplot 360, a fully licensed version, will allow you to load data from multiple sources, so from Fluent, OpenFOAM, Barracuda, you name it. We probably have a loader for you. It'll allow you to load your data from your experimental data as well. You get unlimited CPU, so if you have a 40-core machine, we're going to use all 40 cores for doing the computation. Multiple pages and layouts as well for additional presentation options. And then, again, with the fully licensed version of 360, you get access to Tecplot Chorus, which is good for comparative analysis and organizing your design of experiments type works. And then PyTecplot, you get batch mode, and that's going to be the biggest advantage there. So, Tecplot 360 is really more than just making pretty pictures. Load your data, click a couple of buttons, and make those beautiful plots that I've seen today, but also about data analysis. So you can get more information from your simulations by using the Python APIs and get that faster. And again, I'm just going to plug support@tecplot.com. Please feel free to contact us anytime. CPFD is paying for your Tecplot license, so take advantage of that. So I just want to give a big thank you to CPFD and 5 years of relationship at least, and 3 years of Tecplot for Barracuda being available to you guys. So appreciate your time.